Welcome back, everybody. In this video, we're gonna do word problems.
No, God! No, God, please, no! 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 No!
Apologies for the small text on these examples, but I was way too lazy to write these out by hand. In the first example, a new car originally worth $36,000 depreciates in value by $4,000 each year. Create a model to determine the car's value over time. Then use your model to determine how long until the car is worth $12,000. Finally, plot a graph of your model. There's a lot to unpack in this problem, and perhaps the single most challenging part of it is even getting started in the first place, because translating from English to math can be a difficult task. That's the skill that I'm really going to focus on in this video, is translating from English to math. The very first thing I like to do is find my variable. What is the variable in this problem? Or in other words, what quantity is changing? This is often expressed in terms of the question being asked. This is asking us to determine how long until the car is only worth $12,000. And now I notice the car's value is actually changing throughout the course of the problem or over time, right? So the value of the car, maybe I'll call it V for value. The value of the car is my variable. Okay, now that I have my variable, let's see, where does it show up? And I'll highlight it in orange here. Here's where it shows up, originally worth $36,000. I also see that it depreciates in value by $4,000 each year. Finally, the question is asking me how long until it's worth $12,000. So I notice that there's this relationship between the value of the car and time. Let's break down our first sentence. The car is originally worth $36,000. Now, I know that there is some relationship between B/W means between value and time, which I'll call T. In fact, the value depends on the time. I know that the original value of the car is $36,000. And then if I call, if this is time in years, I'm going to lose $4,000 per year. So this is the model that determines the value of the car. The real question being asked in this problem is how long does it take, T, for the value of the car to be 12,000? That's a single variable equation, in particular a linear equation to solve. 12,000 equals 36,000 minus 4,000 T. Go ahead and pause the video here to see if you can find T. Hopefully we were able to arrive at the conclusion that t should be 6. That means, answering my question in words, it takes, and here let me use a color here, it takes 6 years for the car to reach $12,000 in value. We almost forgot the last part of this problem, which was to plot a graph of your model. Let's do that now. I'll give us a little bit more room here. Because this is a linear equation, its graph will look like a straight line. And I just need to find 2 points on a line to be able to write down its graph. I know that the car is originally worth, if this is t and v, using the ordered pairs t comma v, I know that 0 comma 36,000 is on the graph. I also know, based on what I just found, that it took 6 years for the car to be worth $12,000. So that's another point that I can plot on the graph. Here, it makes sense to just count 1, 2, 3, 4, 5, 6, and so on years, but on our vertical axis v, we may want to use a different scale. Otherwise, we're going to have to go way off the page. So I'm going to count by 6,000s. You are more than welcome to do this on your work, but you should always label your axes if you're not just using a normal axis system. 30 and 36. So I know the point 0 going nowhere horizontally, 36,000 vertically is on the graph, and the point 6, 12,000 is also on the graph. Connecting these 2 points, I can sketch the graph. Let's move on to the next one. The pair of headphones you've had your eyes on for months has finally gone on sale. If you purchased them for $120 when they were 35% off, how much money did you save? Go ahead and pause the video here to see if you can do it on your own. You had to have saved $64.62. This problem is a little tricky for a number of reasons. First of all, this time the question is asking us how much money did you save? But really, that's dependent on the original value of the headphones. Whatever the original value was, we would take the original value minus the $120 we paid to see how much we saved. So V, as I have called it, the original value of the headphones, is our variable for this problem. I know, so that's one layer of trickery in this problem. The next layer of trickery comes from the fact that we are given the sale percentage. So we purchased them for $120, and I know that's 35% off of their original value. In other words, that's 65% of, meaning times, the original value. That leads me to the linear equation 120 equals 0.65 V. From here, it's just like the last few videos we've done. We divide both sides by 0.65, and we get 184.62 as the original cost of the headphones. Now we know how to figure out how much we saved. It's that minus 120, which is $64.62. Unfortunately, there's no way to predict every kind of word problem that could possibly exist. So that's going to do it for this video, but I hope that this has helped give you some practice into how to translate English problems to math problems. Catch y'all in the next one.